Welcome to the deep dive. We look at the latest science to figure out, what's really going on. Today, we're heading out into the solar system looking at those fascinating icy worlds out there, specifically Jupiter's moon Europa. For ages, we basically pictured it as this quiet frozen ball of ice. Kind of static, but get ready because that picture, it's basically being torn up. We've got these incredible new observations coming in from the James Webb Space Telescope, the JWST, and they show something totally different, a dynamic place, surprisingly active inside. So we're going to dive into a study that used this JWST data, it was in the Planetary Science Journal, by Richard Cartwright and Ujjwal Raut. Our mission really is to figure out what this tells us about Europa's hidden chemistry and maybe, just maybe, its potential for life. Let's get into it. Let's peel back Europa's icy layers.
Yeah, it's actually kind of stunning how much things have changed, how our view of Europa has shifted. For such a long time, the standard picture was this still, silent shell.
Yeah.
Not much happening. But the JWST data doesn't just poke holes in that idea. It really flips it on its head.
Okay, so still, silent shell is out. What's replaced it? You mentioned it's dynamic now. What are we actually seeing that tells us that? These chaos terrains.
Exactly, the chaos terrains, that's the key. Think of them as these really jumbled up areas on the surface. It looks like huge blocks of ice have cracked, moved around, almost like icebergs, and then frozen back into place, but all messy. They're like these giant broken ice puzzles.
Huh. So not smooth at all.
Not in these areas, no. And they're crucial because they scream geology. They tell us something's happening underneath. Richard Cartwright, one of the authors, he pointed out the surface ice there seems fairly porous. And in some spots, it's warm enough, relatively speaking, of course, for the ice to actually recrystallize pretty fast.
Which is completely different from a world frozen solid for billions of years.
Totally different. It implies heat, movement, change.
And managing to see that kind of detail, the chemical makeup from so far away, that's got to be tough. How did JWST pull it off? What's special about its NR-spec instrument?
NIR-spec, near-infrared spectrograph. It's perfect for this. It operates in the infrared part of the spectrum with amazing sensitivity. It can pick up the chemical fingerprints, the specific wavelengths of light absorbed or emitted by different molecules, things like water ice, but specifically crystalline water ice, which has a distinct signature compared to amorphous jumbled ice. And it found a specific type of carbon dioxide, too, Uro with carbon-13.
So it's not just seeing that there's ice, but what kind of ice and what else is mixed in?
Exactly. And crucially, it doesn't just get a single spectrum for the whole area. It maps it. It creates these detailed maps showing where these different chemicals are concentrated. It's like having this incredibly sensitive chemical sniver millions of miles away, mapping the surface composition.
And they weren't just pointing it randomly, right? The study focused on specific spots.
That's right. They targeted two of these chaos terrains in Europa's southern hemisphere, Pauis Regio and especially Tara Regio. Tara Regio was highlighted as one of the moon's most intriguing areas.
Why Tara Regio? What made it stand out?
Well, is the discovery about the ice there. JWST found crystalline ice that ordered, structured ice, not just on the surface, but also deeper below, within Tara Regio.
Okay, why is finding it deeper down such a big deal?
Because the assumption was that the intense radiation hitting Europa's surface would quickly degrade crystalline ice into amorphous ice. Finding it preserved deeper down, and even indications of it on the surface in this specific area, suggests it's either relatively young ice or it's being actively brought up from beneath the surface fairly recently. It hints at this active exchange, this churning between the surface and whatever lies beneath. It means the crust isn't just a static lid.
Okay. So the chaos terrains aren't just weird surface features. They might actually be like windows. Windows showing us what's underneath.
That's exactly the idea. They're potential windows into Europa's interior. Because you have this geological disruption, this apparent cycling of material, it makes them prime spots to look for clues about the subsurface, maybe even the ocean.
And that connects to the lab work you mentioned by Ujjwal Raut's team.
Yes, precisely. That work was vital context. They simulated Europa's conditions in the lab. See, on Earth, water naturally freezes into nice hexagonal crystals, but Europa is blasted with radiation from Jupiter. That radiation messes up the ice structure, creating what's called amorphous ice. It's disordered, no crystal structure. The experiment showed how this radiation damage happens, how amorphous ice forms, and how maybe under certain conditions like slightly warmer temperatures, it might recrystallize. So when JWST sees crystalline ice in a place like Terra Regio, the lab work helps us interpret why it might be there, linking it back to processes like upwelling from below.
Okay, so putting the telescope observations and the lab work together, what did they find? What were the big chemical surprises? You mentioned cohosts.
Right. So several things popped out. One really big one was probably the best evidence yet for sodium chloride.
Sodium chloride, like table salt.
Exactly, like regular table salt. And the thinking is it's likely coming from that interior ocean.
Wow. Salt? Okay, what else?
Strong evidence for carbon dioxide, Kioro, and also hydrogen peroxide. But the CoO finding is particularly interesting. It wasn't spread evenly across the surface, which you might expect if it just came from, say, meteorites hitting the moon.
Right, that would deliver it everywhere, more or less.
Yeah. Instead, they found higher concentrations specifically in these chaos regions, like Terra Regio. That strongly suggests it's coming up from inside Europa, probably dissolves in water from the ocean that somehow makes its way up.
And you mentioned it's unstable, the QO.
That's another key point. Carbon dioxide ice doesn't last long on Europa's surface because of that intense radiation. It gets broken down. So the fact that we see concentrations of it implies it must be relatively young. It can't have been sitting there for millions or billions of years.
Meaning it's being replenished somehow.
Exactly. It points towards ongoing geological processes, ongoing activity, bringing this stuff to the surface. It's on ancient history. It's happening, relatively speaking, now. And then there was that specific type of QO, the carbon-13 isotope.
Yeah.
Window.
Okay, what's special about carbon-13?
It's like a chemical tag. Different sources of carbon, say, from meteorites versus from chemical reactions within a planet or moon, can have slightly different ratios of carbon-13 to the more common carbon-12. The details are complex, but Cartwright's comment that every road leads back to an internal origin reflects how this specific isotope signature, combined with its location in chaos terrains, strongly points away from external sources and towards an origin within Europa.
So taking all of that, the salt, the concentrated CO, the carbon-13, the fact it seems recent, it all points inwards.
Pretty much, yeah. As Rao and the team put it, the data showed strong indications that what we are seeing must be sourced from the interior, and most likely interior source. That huge hidden ocean, they think, lies maybe 20 miles or so beneath the ice.
So let's connect the dots. We have these disrupted chaos terrains. We see crystalline ice deeper down, suggesting upwelling, lab work showing how ice behaves, and now these chemical signatures, salt, Kio, Euro, carbon-13, all pointing to an internal source, likely the ocean. What's the big picture here?
The big picture is, well, it's incredibly exciting. It's mounting evidence, maybe the strongest yet, for that vast liquid water ocean beneath the ice. But it's not just that there's an ocean. It's that the ocean seems to be chemically interacting with the surface, or at least the subsurface layers we can probe. You have water, you have chemical solid carbon compounds, and you have potential energy sources linked to geological activity.
Which sounds a lot like the ingredients needed for habitability.
Exactly. Yeah. It makes Europa an even more compelling place to think about the potential for life beyond Earth. All the necessary pieces seem to be there, and they seem to be active. It's moved beyond just being a maybe ocean world to a world with active chemistry linked to that ocean.
And we might get a closer look soon, right? There's a mission on the way.
Yes, absolutely. NASA's Europa Clipper mission. It's already flying, scheduled to arrive at the Jupiter system in April 2030. It won't orbit Europa directly. The radiation is too intense, but it'll make dozens of close flybys. It has instruments designed specifically to study the ice shell, confirm the ocean's presence, measure its depth and salinity, analyze the surface composition in even greater detail, basically, to get the ground truth on this hidden ocean.
So this deep dive really has shifted the view, hasn't it? From this static ice ball to something dynamic, chemically active, this huge ocean potentially interacting with the surface is a whole new Europa.
It really is. And just thinking about what might be swimming or growing or just existing in that dark ocean beneath miles of ice, it's pretty profound. We're looking at potentially whole ecosystems hidden from view.
So here's something for you to think about. If Europa, this moon we thought was relatively quiet, is actually this active, chemically rich world with a hidden ocean, what about the other icy moons out there in our solar system, around Saturn, Uranus, Neptune? What secrets could they be holding just beneath their frozen surfaces? And what does discovering potentially habitable environments like this mean for our whole understanding of where life might be found in the universe? Makes you wonder, doesn't it?